In sections 11.1 and 11.4, I'm going to be introducing you to some basic concepts of probability. So let's go ahead and get started. It says here, use the spinner to the right to answer the following questions. Now, most people have been exposed to some probability, and I think I'd like you to try to answer these questions, and let's see what you know about probability, or at least a basic probability. All right, so on A it says, what is the probability of spinning a 4? Well, if you look at our circle here, there's 4 regions, and each region is the same size, so the chance that you'll get a 1 is just as likely as getting a 2 or 3 or a 4. So in this case, what's the probability of getting a 4? Well, there's 4 possible choices here, and one of them is getting a 4, and so it's 1/4. What's the probability of spinning an even number? Well, there's 2 even numbers, 2 and 4, so 2 out of 4, which reduces to a half. What's the probability of getting a 5? Well, there isn't any 5, so 0 and 4 chance of getting a 5, which would be 0. What's the probability of spinning a number that's less than 5? Well, all 4 of these numbers are less than 5, so that's 4 out of 4, or 1. All right, now before we go on, I want to introduce you, or either introduce you to or remind you of some basic terminology for probability. So if you've got some experience with probability, you might want to try to do numbers 2 through 8 and then watch the video. Otherwise, you can just go along with me here. All right, so it says in number 2, in probability, spinning a wheel, rolling a die, flipping a coin, well, these are all things that are referred to as an experiment. In probability, the act of spinning a 4, rolling a 1, like when we roll a die, or flipping heads is referred to as an event. Notice an event is more specific than an experiment. Rolling a die is general. Trying to roll a 6 would be more specific. All right, number 4, it says in the example above, 1, 2, 3, and 4 are referred to as, these are what we call outcomes. In number 5, it says an experiment is any occurrence for which the outcome is uncertain. For example, when you flip a coin, you don't know what you're going to get. You could get a head, you could get a tail. It's uncertain what you're going to get. Same thing's true when you spin my spinner up above, or anyway, there's many other options. Number 6, in probability, an event is a subset of the outcomes of an experiment. For example, rolling a 6 is a subset of rolling a 1, 2, 3, 4, 5, or 6. All right, so that's the idea there. Number 7, probability is a measure of how likely an event is to occur. And this is something that we're interested in. There's a lot of things in our world that are uncertain. Things that are uncertain, we don't know what the outcome is going to be, and we can use probability to get a better idea of what to expect. For example, insurance companies, they collect data and they know how frequently a teenager is going to get in an accident in their car. And so based on those probabilities, they're going to charge more or less for people to get a policy, an insurance policy. Okay, number 8, it says, the set of all possible outcomes in an experiment is called, this is what we call the sample space. So for example, we said up above, the outcomes were 1, 2, 3, and 4. The set of all of these is called the sample space. All right, let's move on. So on number 9, it says probabilities can be expressed in what 3 ways? Well, you already saw fractions. We can also use percents or decimals. So we've worked with fractions before, and we've changed them to percents and decimals. Let's move on to number 10. It says probabilities have a value between, actually before we do that, let me just give you a quick example. So a half is the same as 50% or 5/10. All right, so now let's move on to number 10. Probabilities have a value between what two numbers? Well, as you would have seen on the first slide, everything between 0 and 1, or all our probabilities, are between 0 and 1. So I'm going to make a little scale here. So we go from 0 to 1 and a half in the middle there. So 0, a probability of 0 indicates that something's impossible. If you're in here between 0 and a half, that means the probability is less likely to, I should say the probability of something occurring is less likely than not that it's going to occur. Of course, if you're in the middle, we sometimes call that 50-50, like when you flip a coin. You know you're going to get heads or tails, and half the time you'll get heads, half the time you'll get tails. Any probabilities between 1/2 and 1, these are probabilities where you're more likely for something to occur than not. And then finally, a probability of 1 indicates that something is certain to happen. Okay, on number 11, it says there are 3 types of probability. For an empirical probability, the probability of an event occurring is determined by observing how frequently the event occurs. So, first of all, I just want to mention in your book, they call these relative frequency probabilities. So some examples would be like the weather. When it comes to weather, weathermen collect data, and based on the data that they see, they make predictions about the weather. And often that data goes way back years and years. And again, one I mentioned before, insurance. When it comes to insurance, the insurance companies collect data, and they understand things like how often people are going to get in accidents, or at what age people are more likely to die. And based on these types of data, they'll decide how much they're going to charge for their policies. And of course, they've got to set it up so that they make money in the end. All right, so that's empirical probability. For a theoretical probability, the probability of an event occurring is determined through a study of the possible outcomes that can occur for a given experiment. These are the kinds of probabilities we were doing on the first slide. We would look at the possible outcomes, and based on those, we would come up with the theoretical probability. Like the probability of flipping heads is 1 in 2. Just based on the fact that we know you could get a head or you could get a tails, and either one of those is just as likely to happen as the other. And so that's what we call a theoretical probability. Now, if you actually flipped a coin, let's say 10 times, that doesn't mean you're going to get 5 heads and 5 tails. In theory, that's true. And yet, when we actually flip a coin, it's not normal that it's going to happen exactly right down the line like that. We'll talk more about that in a little bit. The third type of probability is what we call subjective probability, which is an estimated probability based on experience and or intuition. It turns out that our subjective probability or subjective probabilities tend to not be all that great. In fact, a lot of times we overpredict things or even underpredict. A great example of that is people that are terrified to get on an airplane because they truly believe that they're going to die. The bottom line is you have a better chance of dying when you get in your car each day and you go off to drive to work. If you look at the probabilities, your chances of dying on an airplane are a lot smaller. But that doesn't mean that our feelings aren't going to be different or think differently than that. That's what we call subjective probability. Okay, number 12. If one person is randomly selected from the population described in the chart, letter A, find the probability that the person is female. Now notice this is collected data, and based on this data, we're going to determine a probability. This is what we mean by empirical probability or a relative frequency. So in this case, let's see, the probability a person's female, well, how many females are there? A total of 124 out of a total population of 242. So the probability the person's female is 124 out of 242. And if you simplify that, you get 62 over 121. Now, generally speaking, when we do empirical probabilities, we tend to use a decimal to indicate our answer. So here, if you round this to do 2 decimal places, this would be 51/100ths. So if you haven't already done part B, you might try doing that one. All right, so this one says find the probability that the person never married. So it's just any person. So notice here we have 74 that never married. Again, our total population is 242. So 74 out of 242, we get 37 over 121, or 31/100ths. Describe the meaning of equally likely outcomes. It's kind of hard to do this without kind of doing some circular reasoning, but basically it would go something like this. Each outcome of an experiment is as likely to occur as any other. It's just like when you roll a die. Getting a 6, getting a 1, the chances are equal that you'll get any of the 6 numbers on a die when you roll a die. That's assuming that it's not a loaded die, where a certain number will come up more frequently. All right, that's what we call, because normally we say when we roll a fair die, that means there's nothing going on with the die. It's a normal die. All right, let's move on to the next slide. Okay, it says, assuming the outcomes of an experiment are equally likely, the probability of an event E occurring is as follows in this formula here. So P of E, or the probability of event E, is equal to the number of ways that E can occur divided by the total number of outcomes. Now I like to say it in a little different way. I call it the ratio of favorable outcomes to total outcomes. So in short, I would say fav over tot. All right, so if you look at the first problem here, well, the first part A here, a die is rolled. Find the following probabilities. Well, the probability of getting a 6, well, it's going to be the number of favorable outcomes divided by the total number of outcomes. Well, how many favorable outcomes are there when you're trying to roll a 6? Well, there's only one 6 on a die, and there's 6 total possible outcomes, and so your answer is 1/6. Now, you may want to go ahead and try doing the other probabilities here. In fact, you could keep going until you feel like you're stuck. All right, in B, it says find the probability that you get an even number, again, when a die is rolled. Well, the even numbers on a die would be 2, 4, and 6. So 3 out of the 6 possibilities are 3 even outcomes out of a total of 6, and that reduces to a half. You want to make sure you're always reducing your answers here. Let's move on to C. The probability that you get a number less than 5. Well, on a die, you've got 1 through 4. They're all less than 5. That's 4 outcomes out of 6. So your answer here is 2/3. What's the probability that you get a 7? Well, we know there's no 7 on a single die. And so that's 0 out of 6, or 0. What about the probability that you get a positive number? Well, 1 through 6 are all positive numbers, so that's 6 out of 6, which is a probability of 1. So again, a reminder, probabilities are between 0 and 1. All right, let's move on to number 15. It says the spinner to the right is spun. Find the following probabilities. So the probability of getting a 1. Now, when you do this problem, notice half the circle is a 1, and notice getting a 1 or getting a 2 and 3, these are not equally likely outcomes. It's more likely that you're going to get a 1 than you will a 2 or a 3. Now, one thing you could do to help you out here if you wanted to, actually before we do that, you can see half the circle is a 1, so the probability of getting a 1 is 1/2. But the other way you could do that is the way I was just about to. Whoops, hold on a sec. So we can divide our circle into, these two areas being 1/4 of the circle, and this would be a 1 as well. And so we would say 2 out of 4 or a half for the probability of getting a 1. The probability of getting a 2, that's 1/4 of the circle, so 1/4. And the same thing for the probability of getting a 3. Now 16 and 17, if you haven't already tried to do these, I would encourage you to do that. In fact, I would really encourage you to see if you can think it through and get it right. These are things that I think you can figure out, and they're important basic concepts of probability. All right, so it says the sum of the theoretical probabilities of all possible outcomes is, and you should have said 1. Now it says consider problem number 15. So the sum of the theoretical probabilities of all possible outcomes. Well, in this problem, and with this spinner, there's 3 possible outcomes. You get a 1, a 2, or a 3. If we add the probabilities of each of those outcomes, we'd have the probability of getting a 1 plus the probability of getting a 2 plus the probability of getting a 3. Well, let's see, we would get a half plus 1/4 plus 1/4. Of course, 1/4 and 1/4 makes a half, 2/4 or a half. Half plus a half, we're going to get a 1. In fact, you're always going to get a 1 when you add up the probabilities of all possible outcomes. For example, let's do one more. The probability of getting a heads plus the probability of getting tails when you flip a coin. Well, in each of those cases, you got a 1 in 2 chance of getting a head or a tail. And if you add those up, you get a 1. So this will always work with probabilities. So here's the other one. Number 17, it says in any experiment, an event must occur or not. Either you get a head or you don't when you roll a coin. When you flip a coin. So probability of E plus the probability of not E. Well, let's look at when you roll a die. The probability of getting a 1 plus the probability of not getting a 1. Well, the probability of getting a 1 is 1/6. The probability that you don't get a 1, well, that'd be 2, 3, 4, 5, or 6. So that's 5/6. And notice that does give you 1. So if you said 1, that was correct. All right, let's move on to the next page. And I think I'm going to stop right here, and I'll do a second video.